In question 4, we've got a combination of like a bracket function, and the inside function then has got like e to the x, or it might have a trig function and so forth. Okay, so it's a combination of what we've done in questions 1, 2 and 3. So in this case here, right, when you do dy by dx, okay, using the chain rule, you differentiate the bracket first, yeah? So you bring the power down, 20 down, bracket, okay, and then you reduce that power by 1, which is 19, but then you times it by the derivative in there. So differentiate it, well, e to the x just becomes e to the x, doesn't it? It doesn't change. And 3 becomes 0, so it's just e to the x there. So you end up with, well, there's your answer there. So we could write 20 e to the x bracket e to the x plus 3 to the power 19, okay, with the bracket to the power at the end there. And we're done. So with b then, we've got y equals bracket to the power 5. So if you differentiate the bracket, bring the power down, reduce that power by 1, so you get 4. Then you times it by the derivative in there. Well, 1 becomes 0. E to the 3x, well, remember e stays the same, but e to the 3x, you've got to use the chain rule on that, haven't you? Because you differentiate e, and it becomes e, so it stays the same, but then you've got to times it by the derivative in there, which is 3. Okay, so it's like a function of a function of a function here. You've got the outside function, which is the bracket to the power 4, or up here rather, the outside function, which is the bracket to the power 5. Then you've got the inside function, which involves another function of function, yeah? Because you've got e to the 3x there, with the inside function being 3x. Anyway, we've differentiated the bracket, so we brought the power down, okay, and then we reduced it by 1 to get 4. We then times it by the derivative in here, which is e to the 3x, of course, because it stays the same, and then you times it by the derivative of the 3x there, which is 3. Okay, so you get 15, 5 times 3 is 15, e to the 3x bracket to the power 4. With c, again we got a bracket, okay, to the power 6 this time, so dy dx, well, bring the power down, reduce it by 1, okay, but then you times it by the derivative in there. So differentiate 1, it becomes 0. Differentiate tan, now this is in the formula booklet, it becomes sec squared x, okay, and there's a 4 in front of it attached to it, so that's going to stay there. So it's a constant multiplied by it, so you write it like a sec squared x, okay, so it's in the formula. The derivative of this is in the formula booklet, so you can just check that there if that comes up in the test or anything. So you've got 6 then times 4 is 24, okay, and then sec squared x, and then the bracket. Finally then d, what have we got in d? So we've got again a bracket to the power 8, yeah? So if I differentiate this, I get, differentiate the bracket first, bring the power down, 8, reduce that power by 1, so it becomes 7. Then you've got to times it by the derivative. So if we differentiate sine, of course it becomes cos of 4x, but then we've got to times by the derivative in here, which is 4. So we're using the chain rule again in here. It's another example of a function of a function of a function. So 8 then times 4 is 32. Cos 4x, and then the bracket to the power 7.